Hey everybody, this is Mr. McKee again with SCC 210. Today I'm going to go over Lab 10.2.7, which is using Wireshark to examine a UDP DNS capture. Alright, so we need our CyberOps VM, we need a internet connection, which we're going to be on the inside network. We'll have a default gateway that gets us out to the internet. Alright, and we're going to do some DNS stuff with Wireshark. Alright, so when you use the internet, you use the domain name system, or DNS. DNS is a distributed network of servers that translates user-friendly domain names like google.com to an IP address. When you type a website URL into your browser, your PC performs a DNS query to the DNS server's IP address. Your PC's DNS query and the DNS server's response make use of the user data protocol, or UDP, as the transport layer protocol. UDP is connectionless and does not require session setup that does like TCP. DNS queries and responses are very small and do not require the overhead of TCP. Alright, so that's to let you know, UDP, you don't have to set up a sync ACK, a three-way handshake like you do with TCP. Remember that for some of the questions further down. Alright, and that results in very small responses and does not require the overhead of TCP. In this lab, you will communicate with, and disregard my answers I've typed in. All right, but in this lab, you will communicate with a DNS server by sending DNS query using UDP transport protocol. You will use Wireshark to examine the DNS query and examine exchanges and response exchanges with the same server. All right. So in part 1, you will use commands on your CyberOps workstation VM to find and record the MAC and IP addresses of your VM's virtual network interface card, your NIC, the IP address of the specified default gateway, and the DNS server IP address specified for the PC. Record this information in the table provided. The information will be used in parts of this lab with packet analysis. All right, and I was playing with this earlier, so I want to delete that out because you guys all have different MAC addresses and stuff. Alright, but now follow the directions down. Don't try to get all this information right now. Or if you don't know how to right now, that's fine. Alright, so your CyberOps workstation VM network settings should be set to bridged adapter. To check your network settings, go to machine. Now I'm using VirtualBox. If you're using VMware, it's going to be a little bit different, but it's pretty close. Alright, click on network, and notice I have bridged adapter. So what it's doing, this VM is on the inside of a network, and it's getting a network address from my DHCP server, which is my firewall. Alright, if you set it to a NAT, that's going to do a NAT translation, so you can have a different IP address in there, and it's not going to do everything it's supposed to be doing. Alright, but set it to bridged, and it'll pick up an IP address from your from whoever's whatever machine is giving out your DHCP IP addresses. Alright, so that's set. I'm going to close that down. Alright, open a terminal in the VM, enter ifconfig at the prompt display to display interface information. If you do not have an IP address on your local network, run the following command in the terminal. So basically you're going to set up a DHCP and say if you have a static IP address. Alright, so I'm going to do ifconfig. Alright, notice this IP address that's listed, that is on my network, that's valid IP address. There's my subnet mask, which is the same thing as /24. Alright, some other information, let me see. Here's my MAC address. Notice 6 sections separated by colons. Alright. So now that gives us the MAC address and the IP address, but now if we go to use cat /etc resolve.conf, where did I type? Cat Let's see what my directory is. Analyst. Oh, it should be there. Cat. How many I typed it in? etc. Oh, I was spelling resolve wrong. All right, resolve.cnf. All right, so that shows me that is my valid IP or domain name server that I'm using. All right, that's another domain server. All right, so now at the terminal, type in netstat with an RN option. All right, and that shows here's my default gateway in my case. All right, it's also listed down here. Remember, for some of the networking classes, if you're in those, if you see all 255s, that's referring to one specific IP address. In this case, that IP address. All right. Notice this is my network. .0, 255, 255, 255, 0. So there is 256 possible addresses. One's taken up by the right here by the broadcast, right, on this network. One's taken up by the network itself. All right. And in this case, actually, one's taken up by also by the interface for the subnet mask. So really, I would normally have 254 addresses left over, but I have 253 addresses left over. Just a fun fact there. All right. So that will answer. Let's see. You know, the DNS IP and default gateway IP address are often the same, especially in small networks. However, any business or school network, the addresses will most likely be different. All right, so you can go through now and fill in the IP address. So it's kind of like scroll up to where you did ifconfig. All right. Mine's 192.168.254.90. And if you had it set to NAT, you're going to get a different IP address, like completely, and you'll have some more settings too in VirtualBox. I usually use VMware Workstation for if I'm running it on a PC, so it'll be a little bit different, but it'll assign IP addresses. It'll do stuff like that. All right. So this is my Mac. All right. So 08:00:0:2087:B9:15:14. Notice that's in hexadecimal. All right. 48 bits. 2, 3, 4, 5, 6. 6 times 8, 48. All right. Okay. Default gateway address is down here. 192.168.254.252. DNS server address is right here. You can use either one. That's just the primary. All right. So I scroll back down and let's see. Close that down. In part 2, you will set up Wireshark to capture DNS query and response packets. This will demonstrate the use of the UDP transport protocol while communicating with the DNS server. In the terminal window, start Wireshark and click OK when prompted. So at all right. In the Wireshark window, double-click the ENP0S3, which I've already had that selected. Notice I have traffic on there. Notice the little graph that's forming, and if I mouse over it, it'll show me my IP version 4 and IP version 6, my link local address, IP version 6 address. All right, so double-click that. You know, on this network, I'm going to get a whole bunch of stuff because I've got different things running for for different lab stuff. All right. So we started that. Open the web browser. Go to google.com. All right, then click stop right here, red square. All right, it stopped. All right, so analyze, capture DNS or UDP packets. In part 3, we'll examine the UDP packets that were generated when communicating with the DNS server for the IP address for www.google.com. All right, in the Wireshark main menu, type DNS. All right, because we got a whole lot of packets, like a whole lot. So there's like 1,170 packets in there. I want to narrow it down just to the DNS related packets. All right. And then it says quick reply. I hit enter and that does the same thing, but here's what it looks like. There is a arrow pointing towards the right. Apply display filter. I've already done that, so it's grayed out. All right, so all right, if you do not see any results after the DNS filter was applied, close the web browser. In the terminal window, type ping as an alternative to the web browser. We had plenty of traffic coming back, so we're good. In the packet list pane, which is the top section, locate the packet that includes standard query. All right, if you notice right there, standard query and a standard query for Google. Notice detect portal, Firefox, that's not the one we want. If you see the 4A packet, that's actually IP version 6. So a single A is IP version 4, but it doesn't matter for what we're doing. Let me try to scroll down and find it. If I can type it in Google. Whoops. No, it doesn't like that. Google. DNS. Digicert, Mozilla. There's Google. All right, here's one. Here's a good example. All right, standard query and a google.com. That's number 228 for my packets. All right, and notice his frame up here. He has the domain name DNS query open. All right. Standard query. Standard query. All right. So examine the fields in the DNS query packet. The protocol fields highlight in gray are displayed in the packet details pane, the middle section. All right, in the first line, the packet details pane, frame 429 had 75 bytes of data on the wire. Let's see where mine is. This actually had 70 bytes. This is not exactly the same, but we'll use it. 70 bytes on the wire. All right. This is the number of bytes it took to send a DNS query to the name server requesting the IP address of google.com. If you use a different web address, such as cisco.com, the byte count might be different. The Ethernet 2 line displays the source and destination MAC address. So that's the second. And if I unhide that, it shows more information, but I'm going to hide it. Ethernet 2 frame. All right. That shows the, now notice one thing, let me see how theirs looks. Okay, so there's like similar to mine. The OUI, which is the first three sections of the MAC address, this is just resolving it to the actual manufacturer, because that OUI tells you the manufacturer of the MAC address. But mine says Palo Alto, and the other one says PCS, uh, probably computer, which is a virtual, that's like a VBox, or I would assume a VBox name. All right, because if you do it in VMware, it definitely it should shoot as VMware. All right, so the source MAC address is from your VM because of your VM or originated the DNS query. The destination MAC address is from the default gateway because it is the last stop before the query exits the local network. Is the source MAC address the same as the one recorded from part 1? Let's go look. Source MAC address. Notice it is the same. 1514 is the last two sections. All right, where was I? All right, so we can answer that. All right, in the Internet Protocol version 4 line, which is right here, let me minimize Ethernet 2, IP version 4 line. Okay, IP packet Wireshark capture indicated that the source IP address of the DNS query is 192.168.8.10 and the destination IP address is 8844. In this example, the destination address is the DNS server. Can you identify the IP and MAC addresses for the source and destination of this packet? All right, so MAC address, I'm not going to fill these in, but MAC address, notice source, and this needs to scroll over a little bit. All right, source and destination IP address, and source and destination MAC address. Notice SRC source, DST destination. All right. Note the destination IP address is for the DNS server, but the destination MAC address is for the default gateway. Okay, because that frame is going to be the encapsulation of the frame is going to be stripped off of the packet, and the packet is going to be reassembled on the other side and sent over to the next hop on the other side of the firewall. All right. If the IP packet and header encapsulates the UDP segment, the UDP segment contains the DNS query and the data. The UDP header only has 4 fields: source port, destination port, length, and checksum. Each field in the UDP header is only 16 bits as depicted below. All right. Click the arrow next to the user datagram. Notice that there are only 4 fields. All right, the source port number, source port is this, that 34569. The source port is randomly generated by the VM using port numbers that are not reserved. The destination port is 53, which is DNS. Port 53 is a well-known port reserved for use by DNS. DNS servers listed on port 53 for DNS queries from clients. All right. So that's that. In this example, the length of the UDP segment is 40 bytes. The length of the UDP segment for your example may be different. Out of 40 bytes, 8 bytes are used for the header. Or the other 42 bytes are used for by DNS query data. All right, so scroll up a little bit. All right, so we can see protocol UDP, header length. Let's see, actually. A whole bunch of stuff in there. Let's see what they got. Alright, so the checksum is used to determine the integrity of the UDP header after it has traversed the internet. The UDP header has a low overhead because UDP does not have fields that are associated with the three-way handshake in TCP. Any data transfer reliability issues that occur must be handled by the application layer. Alright, so expand as necessary to see the details. And what they're looking at is, let's see, UDP. Alright. Let's see, DNS query. Okay. Okay, so basically up here, frame size 70 bytes, source MAC, destination MAC, source IP, destination IP. That's all the stuff we've just looked at. Source port and destination port. Is the source port address the same as the local PC's IP address that you recorded in? Let's see. So it is the same port or the same IP address. Is the destination IP address the same as the default gateway? You can see right there, it actually is not. All right, examine the fields in the DNS response packet. All right, so in this step, you will examine the DNS response packet and verify that the DNS response packet also uses the UDP. All right, in this example, frame 488 is the corresponding DNS response packet. Notice the number of bytes on the wire is 90, is the larger packet compared to the DNS query packet. This is because DNS response packet will include a variety of information about the domain. All right, notice here, it's 86 bytes. All right, standard query response. All right, google.com. And notice right here, you might see so it's like it's got a multicast going on. Like you send it to 8.8.4.4, it's using a range of servers, so different IP addresses. All right, so that's why you get that. If I did it again, I might get a different IP address from the response. All right. So the Ethernet 2 frame for the response packet, query response. All right. So destination, source. What device is the source MAC address and what device is the destination MAC address? Notice, since we're talking about MAC addresses in frames, the source is my firewall, which is my router, and the default gateway. All right, and destination is my PC, or my virtual machine PC. All right, notice the source and destination IP address in the IP packet. All right, source 8844, destination. All right, what is the destination IP address? What is the source? So it's coming back, it's responding to my request. What happened to the roles of source and destination for the VM and default gateway? Well, the reason you're getting that, I explained that earlier, but since that frame's coming in, the frames won't go across a router, the router de-encapsulates the frame, looks at the packet and puts it back on the wire on the other side and re-encapsulates it. That's why you're getting, because it won't send MAC address information through there. Or it won't, let me be specific, it won't assign the destination based on the MAC address. It'll use the IP address. Alright. So hopefully that makes sense. But it re-encapsulates it, that's why you get a destination. Alright, that makes more sense because that's going back to me, but it's coming from my firewall. Alright. It can't come from this IP address because that's not on my network, and it's through at least one router. So, you know, after every time it goes through the router, it de-encapsulates it, looks for the IP address, and sends it on. All right. So let's see. When a DNS response is expanded, let's see if I can. Who's expanding? Answers. All right. Notice the resolved IP address for google.com. Notice how we went to 8844, but it's actually going to 172.1.217.14. And see actually their instructions are 172.217.14.196. So it's like a multicast or anycast. So it's actually referred to as anycast. You have a list of IP addresses or destinations you can go to, but your source is going to be 8844. Anyways, all right. So what are the benefits of using UDP versus instead of TCP as a transport protocol for DNS? If you look at the beginning of the lab, it explains that. All right, but it's size, speed. You're just doing the benefits. All right, and that's it. All right, fairly quick lab, but that's it. Just go ahead and fill out those answers, and the all these are considered answers too, and as well as those and those right there. I just didn't fill them out because I want you guys to do them yourselves. All right, but that's it. Thanks for watching.